logarithmic differentiation. Well, the next two examples will demonstrate the power in this technique. So let's go and look at the first example. In this example, we have a nasty looking function, looks like this, x raised to the power of 3/4, and we have a quotient here, and then times the square root of x squared plus 1, all of it is divided by the quantity 3x plus 2 raised to the 5th power. Okay, so we're looking at this, and of course, as expected, we need to find the derivative. So we're looking at this, and depending on where you're from, but you look at this and say, oh, oy vey. I mean, this is really a tough one right there. Well, we have a product, and we have quotient, and then for the product, we have a chain rule here. We have double chain rule here, one for the square root and the other for x squared. And we have double chain rule here, one for the power and then for 3x, even though that's an easy one. So if you add all the operations here, you end up going through 7 steps to solve these. So what can we do to alleviate this? Well, here's one thing that we can do. First of all, we can apply the natural log to both sides. Hence the title, Logarithmic Differentiation. So what happens if we do so? When on the left we have the natural log of y. On the right side, we have a natural log of a product and a quotient. So I can write it as the natural log of x raised to the power 3/4 plus the natural log of the square root, but I know where I'm heading, so instead of radical form, I use power form, so it will be the natural log of the quantity x squared plus 1 raised to the power of 1/2, and then instead of dividing, well, in lieu of dividing, it will be, I'll subtract the natural log of 3x plus 2 raised to the 5th power. And apply the power rule of logarithm, and it will be 3/4 natural log of x plus 1/2 natural log of x squared plus 1, and then minus 5 natural log of 3x plus 2. You know, it's already looking much better than where we started with, because instead of dealing with product and quotient, all we need to do is find the derivative of logarithm 3 times. So next I'm going to differentiate both sides, and this is of course implicit differentiation, and get the derivative of natural log of y. Well, the derivative of natural log of something is 1 over that something, so it will be 1 over y, and then the derivative of y is simply y prime. This is something that you're going to see about 2 or 3 more times today. The derivative of natural log of y will be y prime over y. A little bit of differential expression taken from differential equation, where you have in the same term, you have the derivative and the function. So the derivative of natural log of y, y prime over y, and then now we differentiate the right side. Well, it will be 3/4 derivative of natural log of x plus 1/2 the derivative of natural log of y, where y equals x squared plus 1. So it would be 1 over y, or 1 over x squared plus 1, but we need to multiply it by the inner function, the derivative of x squared plus 1. Well, this is 2x. Minus 5, the derivative of natural log of 3x plus 2, well, that will be 3x plus 2, and the derivative of 3x plus 2 is 3. One more step to simplify. We end up 3 divided by 4x plus 2 and 2 cancel each other, x over x squared plus 1, and finally negative 15 over 3x plus 2. It's not bad, isn't it? It's also easy to process, but this is y prime divided by y. I need y prime by itself. So we bring it home by saying y prime equal y times this thing. And I'll stop right here. I think, unless I'm instructed to solve or simplify completely, that's a pretty good solution right there. I mean, I know what's y. Y is this thing. So if somebody is not happy with this result, I can plug in this expression over there. We can also work on the quantity in the parentheses, find common denominators and see if something will be reduced by collecting like terms. But at this point, I'm happy with this result. Again, it depends on the instruction. If something like this will show up in a test, I'll give you specific instructions whether you can keep y in your answer, then I'll be happy with this. Or if I want you to simplify completely, in other words, I don't want y in the solution, I want only terms in x, reduced to the simplest form. Okay? So this was one example. The next example is also odd-looking function that looks like this. Y equals x raised to the power of square root of x. Note before you proceed, x raised to the power of square root of x is not a power function. Some students try to apply the power rule here, but of course you cannot do it because this is not a power function. So what are we going to do with the solution? Well, the same approach. Remember the two steps. We apply the natural log to both sides. So we'll do the same thing. We'll apply natural log to both sides. Okay, so this BS is not the brown stuff, but both sides. And we have natural log of y equals natural log of x raised to the power of square root of x, or applying the power rule, square root of x times natural log of x. And then take the derivative, so now differentiate both sides. Again, this is implicit differentiation. And the derivative of natural log of y is y prime over y. Okay, I told you you're going to see it again. And then on the right side, I have a product. So I need to apply the product rule. The derivative of square root of x is 1 over 2 times square root of x, multiplied by natural log of x, and then the square root of x times the derivative of natural log of x, like so. And a little bit of simplification won't hurt us here. So it will be 1 over 2 square root of x plus square root of x divided by x is 1 over square root of x. And the common denominator will be 2 square root of x. So it will be, there is a natural log of x here. So it will be natural log of x plus 2. Okay? Just by setting the common denominator. This is y prime over y prime by itself multiplied by y. But what is y? Y is this x squared of x. I tell you, I'll do it in 2 steps. So it will be y times natural log of x plus 2 over 2 square root of x. And we end up having, for a solution, we're going to write it like this: natural log of x plus 2 times y, which is x raised to the power of square root of x, all of it divided by 2 over square root of x. Again, it's an odd-looking function with an odd-looking derivative, but otherwise it will be, in this case, it will be impossible to differentiate without using logarithmic differentiation.